Hey, math analysis students. It's Monday morning, and I'm thinking I'm going to try to make you as many videos as I can today so that you can have the flexibility the whole week to do which ones you want to do. So these are for homeworks 54 through 57. We're finishing up matrices today, and then 11.1 and 11.2, 11.3, they are more towards the end of the week, is on 3D vectors. So all information that you'll need for the future. You won't need this information for AB calculus next year, but you will need to know it for future math classes in college. Okay, so let's get started. So this is 8.5. Okay, and this is actually the last lesson on matrices today. So this is applications of matrices and determinants. Okay, and actually we're going to be doing 8.2, a little bit of 8.2, and a little bit of 8.4 also in this order. Okay, so let me show you what we're doing. It's kind of cool. We're going to be learning how to operate most things, but we're not proving that they work. So the first thing that I want to start with is something that I find very intriguing that it works. I actually don't know why it works. It probably has to do a bit with vectors, but I don't know. It's very interesting. So what you have is you have a triangle that's like slanted. So it's not a right triangle necessarily, but you have a triangle like this, and you want to find the area of it. So try to think of how you would attack it if we didn't have a method. So I'm going to write some coordinates for these. Okay, but just be thinking, how would I attack this? This is 1, 1. Let's say this one's what, maybe 7, 4. This one is, let's say what, 3 higher than 4, maybe 2 higher than 4, let's say 6. Okay, so 3, 6, 7, 4, 1, 1. How would you find the area? So what do you think? Now you've done it before, potentially. Maybe find the base, right? Find the base, and what's our main area for triangles? Find the base and the height, 1/2 base times height, right? So you could do that. How would I find the height? How did you find the base? The area, the length of the base? Length of the base, distance formula, right? Would have a square root. So the base would have a square root. How would we find the height? The height's perpendicular. What's perpendicular mean? Well, look at the green line. What could you do? You could find maybe the slope of the green line, right? Then what? How would you find perpendicular? So you have the slope. Say the slope was, well, the slope is 1/2. So what would the slope be of the other? What could you do? Remember, perpendicular is, so it'd be -1/2. Flip it and change the sign. Okay, but I would have the slope of the kind of the H location, but I wouldn't know where it would be. Oh, it goes through this point. So maybe I would do like y minus y1 equals mx minus x1 with that perpendicular. I would then have to find out where they meet, find that point, find the length, square root, and then find it. Okay, so to me, it's really fascinating that the way we're going to do it has no square roots in it. It always has fascinated me like that. The other thing, what else could you do? Did you think of another way instead of that way? What about law of sines, law of cosines? Right? Remember there was a formula. Let me do this one in red. Say you had theta. If you found the theta, couldn't you find like side 1, side 2? And the formula was 1/2 side 1 times side 2 times the sine of theta was the area formula. That was from, I think it was this, maybe chapter 6. Yeah, chapter 6. So something that will be on our final eventually. Anyway, so that's very interesting. Side 1, side 2, distance formula, but how are you going to find theta? I guess distance formula. You can always use Heron's formula with distance. Heron's formula has a square root. Each of those distances have square roots. It's very interesting. So we have all these ways, but somebody figured out another way. They derived another way. I don't know who it was. It doesn't have anything to do with this, at least when you're showing the work for it. It's super straightforward. It's a little strange. Okay, it's area of a triangle equals this. Now, what did that mean? Did that mean a matrix or did that mean a determinant? Okay, so that's a determinant. And what you do is you write your coordinates, your x1, y1, and your x2, y2, and your x3, y3. So you write those. And that the y's are actually in their own column. Okay, so y1, y2, y3 of your 3 points. Doesn't matter the order. And then you fill in, I'm going to put this in red, you fill in a 1 here. So you have to memorize that you're filling in a 1 there because it does have to be a square to be to find the determinant. And how fascinating is this? This doesn't have any square roots. Anyway, so then you figure out which way you want to do it. You can do the down, 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 right? Down, 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 minus up, up, up way, which is my favorite way. You can also use the cofactors idea, which is where you take the x, right? And then you multiply it by the determinant of these. And then you take the y, negative, that one, and then the determinant of the first and the last. Anyway, so you have whatever ways you want to do. I like the blue and the yellow way. I like the downs minus the ups, so that's the way I'm going to show you. But any way will work. Okay, so let's try this one. So we'll try this one. We're going to call this one example 1. So this is a formula. Oops, sorry, I hit my button. Formula. I'm using the pen that came with my tablet instead of the one that came with my phone, and it's a little different in my hand. Okay, so the area, oh, and actually there's another part of this formula that's kind of cool, is I'm going to put it in red on top of it. Okay, and then you'll see what that means. It's kind of fun. I'll show you what the red one means after. Okay, so we get, let's see, x1. It doesn't matter which one you choose. So let's say we have 1, 1, and then 3, 6, 7, 4. So the order doesn't matter in these. Then you fill in 1s right here. And you do always fill in 1s. And again, I don't know why this works. So maybe I'll have time during the break to figure out why it works, because to me, it's fascinating. Okay, so 1, 3, 7, 1, 6, 4. This is the way I like to do it, right? With determinants, with 3 by 3 determinants in the last video, I like to do down, 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 minus up, up, up. So to me, that's when I get them right most often, which is ironic since in that last video, that's the one I made the mistake in. So that was very funny. Okay, so this would be 6 is the first yellow down. You multiply, plus multiply the 1 times 1 times 7 down, that's 7. Multiply the 1 times 3 times 4 down, that's 12. Minus the blues. 1 times 6 times 7 is 42. 1 times 1 times 4 is plus 4. And 1 times 1 times 3 is plus 3. And then this would be 13 plus 12 minus 49. 749. Okay, so this is 25 minus 49, which is negative 24. But this is area. So what's the problem with this being the area? So this is the determinant. Okay, so the determinant is negative 24. But what's the area? Well, area is not supposed to be negative, so that's where the absolute value comes in. So my red absolute value from above. So the absolute value also means determinant, right? So the black absolute value was a determinant. And then this is an absolute value where it comes with a real absolute value. Okay, so this outside red right here, I'm writing this towards the top. This is an absolute value. Okay. Basically, I need area to be positive. Okay. I need area to be positive. Cool. So that's it. So it's very straightforward. It's not all that complicated. Find the perpendicular, find the length of the sides with the square roots. It's just, like I said, fascinating. I want to work it out the other way and see how it works. Okay. So there's another one where they give you 2, 3, negative 1, 7. So this is example 2. Okay, I'm just kind of running through the homework questions related to this. And then they give you another one. It could be the X is missing, or it could give you the Y is missing. So let's give us this one. And then it says the area is, and it tells you what the area is. Okay, so they give you an area. So say they give us an area of 5, and then they say find X, or find Y, find the missing coordinate. Okay, so this area, same idea. So we have 2, 3, -1, 7, x 4. Fill in your ones. Maybe the colors will help, because sometimes people forget on the test that they can fill in the ones. Okay. Okay, so down, 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 minus up, up, up. Okay. Now, the only thing is, remember, there is an absolute value on the outside of this determinant. I'll just put it way over here. But there's an absolute value. So I want this absolute value to turn out to be 5. Okay, so there's going to actually be 2 answers for X. Okay, so the yellow. So yellows minus blues. Okay, and you multiply down each. Okay, so multiply down would be 14 plus 3x minus 4. And then multiplying up, that would be 7x plus 8 minus 3. Let me try to double check. 14, 3x. I really like you guys being in my class to double check. We need a live video so you guys can say, hey, Miss Nichols, look, that 8's supposed to be a 6. Okay, except I think the 8 is supposed to be an 8. -3. Okay, now that still has an absolute value technically. Oops, hit my button again. Technically, and that equals 5. So really, you're going to get that this is plus or minus 5, which is very interesting. So you actually have 2 equations, because if it was positive 5, it would give you an area of 5, or if it was negative 5, it would also give you an area of 5. Okay, so this is 10 plus 3x minus 7x minus 5, right? That's positive 5, and then I distributed it, negative. So that would be -4x plus 5 equals plus or minus 5. So -4x minus the 5 on both sides. So that would be, I'm going to split it into 2. -4x equals, well, I'll put it here for now. So that would be -4x equals 5 minus 5, and -4x equals -5, -5. So -4x equals 0. That's just a coincidence. X equals 0, and this is -4x equals -10. Divide, x equals, reduce the fraction, divide by -2, and that would be 5/2. I have made it so you can comment on the videos now. I looked up the word kids in YouTube, and it says less than 13, or 13 or less. You guys are way not near 13. So, well, not too way near, way far, but far enough away from 13 that I think we're good. So I remove the kids label, which means you can comment. So if I do make a mistake, please put it in the comments of the YouTube video, and then other people will see it too. You can also put that in the Google Classroom. Okay, so that's example 2. Another application that is related to that is collinear. Okay, now collinear. Now, what does collinear have to do with area? Remember collinear? So collinear is when 3 points are in a straight line. Now, I usually think of it having to do with slope, and that's actually how we're going to do it when you're in chapter 11, which is 8 and 11 are very linked, the 2 chapters. So I usually find the slope, and the slope should be the same. So that's my normal plan. But they're saying use a determinant. So they say use a determinant to prove, the points are collinear. Okay, so, how would area, which is what determinants are, how would area relate to these 3 collinear points? So if I connect them together, right? Now imagine this. Imagine they weren't collinear. Let me lift the just barely off. So look at this triangle, and then look at the triangle, my yellow triangle here, and compare that to my blue triangle. What's the area of the yellow triangle? So what's the area of this one? Now I don't know what the blue triangle is, but I know the area is positive. What's the area of the yellow triangle? It would be 0. So the area of the triangle is 0 if collinear. Okay. Or there's a word in math, it's called if and only if. It's called IFF. Okay, and that means that if the area is 0, then it's collinear, and if it's collinear, then the area is 0. So it means it works both ways. So how about if I just draw an arrow? This is an official math symbol. Okay, the double arrow, it means if and only if. So it does mean that if the area was 0, then it's collinear. If it's collinear, then the area is 0. So it works both ways. Okay, that was called the converse and the original statement back when you were in geometry. Okay, so let's see. Let's have 3 points and determine if they're collinear. Well, I mean, we really don't need to. How about our 3 points above? Look at example number 1. Were those 3 points collinear? They weren't, but how do we know? What was the area? 24? So the area has to be 0. So basically just, let me just put plan, find area. If area equals 0, then collinear. Okay, and then how do you find the area? You do this, right? x1, y1, 1, x2, y2, 1, x3, y3, 1. And if that turns out to be 0, then it's collinear. There's also a question that says, I believe there's a question that might say it is collinear, find the x, and that would be done the same way as example number 2. So back to this one, I'm going to say use method of example 1. Okay, that'll save us some time. Okay. So let's see our next one. Kramer's rule. Okay, this is totally different category. It's used not for area, so that whole part above was an application of area. This one is another method to solve a system. Okay. And it's called Kramer's rule. I used to use Kramer's rule a lot, actually, when I first got my calculator, because I didn't know about RF. But RF is much more powerful than Kramer's rule. So now I tend to just use RF if I'm using my calculator. And if I'm doing it by hand, Kramer's rule doesn't always work. And since Kramer's rule doesn't always work, and Kramer's rule is about equal work as an augmented matrix, I usually choose augmented matrices instead. Okay, but it's still valuable for you to see. In case somebody uses it in your future math class, you're not like, what the heck, what did they do? Okay, so let me give you the way to do it. So ax plus by equals c, and dx plus ey equals f. Okay, this is the 2x2 version. Okay, so this is the 2x2 version. And then there's a 3x3 version as well. So that would be ax plus by plus cz equals d. And then what, ex plus fy plus gz equals h. It's so weird to see e and I in these equations because e and I usually stand for something else in math. Ei, and then j too. J is something else in vectors. So jy plus k z equals L. Okay. So what it turns out to be, it's pretty nice if you just wanted one letter and if there was one letter that you could find. And let me show you how it works. So x equals, okay, and then I'm going to put y equals, comma, okay. Now, I always do the bottom first. Okay, so let me do the bottom in green. Okay, so the bottom determinant of this Cramer's rule. Okay, bottom determinant of the Cramer's rule is the coefficients of the variables. Okay, so A, D, B, E. A, D, B, E. So what would the 3D one look like? So think of the 3D one. So what would the 3D one look like for the denominator? Okay, so you just grab these. E, F, G, I, J, K. And make sure you're using vertical bars because that means determinant. On your augmented matrices, you're supposed to use the brackets because that means it's still a matrix. You're not finding the determinant. The determinant is just a number that you're finding. But the matrix, if you wanted to keep it intact, you use like for an inverse or something, or for augmented matrices, you have to use the brackets. Okay. So how it works is if you're solving for x, so I'm going to highlight this with x. If I'm solving for x, then I put the CF in the column where x is usually. So my x column is the first column. So I'm going to put the CF in the x column. And then I copy the bottom row right here, or the bottom column. Okay, so the other column stays the same, and you are putting the CF in its spot. And of course, these can be derived. Okay, so they can be made, but we're just seeing how they work, not how they were made in the first place. Okay, so for this one, CF, if I'm solving for y, I put it in the y column. Oh, let me put that in red so you can see better. So I put that in the y column, so CF. So then what do I put in the other column? I just raise the one below it above. And that's it. And remember determinants. Okay, so how would you find one of these determinants? You do downs minus ups. Okay, same on all of them. Down minus up. Down minus up. Down minus up. I do usually calculate the bottoms twice in the 2x2s just to make sure that I didn't make a mistake. Now, when would this give you an error? Okay, when would this give you an error in your process? So this only works when what? When would you type it in and get an error in your calculator? It's when the determinant here is what number? When would you get an error? Okay, you would get an error with 0, but I put this only works when. I could change it to it does not work when, but it only works when this is not 0. Okay, so it only works when the denominator is not 0. Okay, so what would we do for the x here? So who's my red column? So my red column is the numbers column. Now, if I'm solving for x, I put that in this spot. And then what do I do for the rest? That's not 2 bars. That's just a change to green. What would I do with the rest? You just bring up these guys from the bottom. C, G, K, B, F, J. That's it. And then you can do your down, 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 minus up, 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 down, 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 minus up, 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 by duplicating the first 2 rows. Okay, just the way that we did it in the other ones. Or you can do it the other way, which is in another video on how to find determinants of 3x3 matrices. Okay, so let's see, that's if I want to find x. So try it for y and z. Okay, so try it for y and z. Pause the video, see if you can get the y and z ones, and then you can check it with mine. Okay, so don't just copy mine. Okay, so put your denominators. Okay, so your denominators. Oops. And your numerator. Oops. My numerator. And remember, you're putting the red in the column that you're solving for. Okay, so if you're solving for y, you put it in the middle column. If you're solving for z, you put it in the last column. So DHL. And then this one, DHL. And then you fill in all the rest. AEI, CGK. AEI, BFJ. Okay, and that process is going to make it so you can do Cramer's rule. And we won't actually do an example. I think you're going to be able to get it from this. I think if you just go with the formula and then you work out your determinant, remember down minus up, you're going to be great on this. Okay, there's nothing tricky from there. If you do get a 0, it doesn't mean there's no answer. It actually means that it might be one of those weird z equals t ones from augmented matrices. So it might mean the three planes meet in a line instead of in a point, or it might mean no solution. So it doesn't necessarily mean no solution if you do get 0. Okay, it means that Cramer's rule failed. Okay, so let's put that here at the bottom. We'll put note. If the determinant, and I'm not putting the letters in because it could be 3 by 3 or 2 by 2 or 4 by 4 or any levels. Okay, so if the determinant is 0, then it's no solution or infinite number of solutions, which is totally different. Okay. Use augmented matrices. To solve. So it's very sad. So that's the only problem with Cramer's rule. And I mean, it is a nice formula though. So if it worked for everything, then maybe we would use it more, but augmented matrices is more powerful. Okay. So the next thing we're going to do is a small example, and then we're going to go to the next section. So the next section would be 8.2. Okay, but this was actually, that was 8.5. This is actually an 8.4 example. There's a couple of things I think in 8.4. I think you'd be able to get this anyway. I don't really think that you need the help on this one, but let's see. Let's just make sure. So it says this equals 2. Let's say this equals, let's see what it equals. We'll have this equal, oh, that's interesting. I'm now trying to solve it in my head. We'll have this one equal 99. Okay, so how do you solve this? What do you think? So what do the bars mean? Down minus up, right? So down minus up, downs are multiplied. Minus up, ups are multiplied. Okay, I messed that one up. Okay, let's change from 99. Okay, so let's change. That's what I get for solving problems in my head here. Okay, so let's have it equal 24. Okay, and then add 75, x squared equals 99. And then how do you solve this? Right, you square root both sides. In my class and in calculus, you'll need to know that if you take the absolute value of something like this, you get an absolute, or a square root of a squared, you get an absolute value. 99 is 11 times 9. That's what? 3, 11. So 3 radical 11. The 3's come out. And then x equals plus or minus 3 radical 11. That's it. And then let's see, I think this is example number 3. I'm going to scroll up just to check. That probably bothers you when I scroll up. Okay, so example 2. Okay, so this is example 3 if we're labeling. Example 3. Okay, so that was 8.4. There might have been another couple questions in 8.4, but I think that you're going to know how to do them. So I didn't think that you needed an example for them. Okay, so this next one is 8.2. We're basically just going through all the application problems. Okay, so say you're working for a company. So these are actually word problems. Okay. Okay, so this is a word problem. So say you're working for a company and you have prices on a lot of different things. Okay, so these are going to be prices. Okay, so say I have small, medium, large, extra large. Let's say they're shirts. Here's female shirts. Here's male shirts. Okay, so then we have prices. So this is how much it's costing you from the company. So this one's $5. This is mediums from the company, also cost $5. Larges cost you $6, and extra larges cost you $7. So this is how much you're paying, okay, as the company. And then that's for the female shirts. Now the male shirts are a little larger, so this is 6, this one's 7, 7, and 8. And it says something like this. It says, the company says, we're going to raise the cost by, say, 15%. Now, you could do each individual one, right? You could say 5 times 0.15, and then you get 0.75. Then what would you do with the 0.75? Wouldn't you add it back to the 5? So 5.75. And I could do that on every single one. Okay, but imagine there were, like 100 items, and it wasn't just this type. Maybe there's other types of shirts. There's long sleeves, there's short sleeves, there's, when we're talking about the females and the males, it's really just the females are like V-necks and then the males are like circular neck. So, but what if there were other types? Sometimes the males like the V-neck and the females like the circular neck. So maybe the cut's different, for the intake of the waist, or maybe they're heavier ones and colors. And there could be all sorts of possibilities. So what could we do just to make every number come out to be or to be 15% higher? So what this actually is this is saying that you're doing a number. So I'll call it A. So this is A plus 15% of A. So this is actually 1.15A is how you would increase it by 1%, by 15%. Okay, so all you would have to do, if you think about it for this matrix, is remember, for a matrix equation, you could type this into your calculator, this matrix equation here, and you could do that 15%, that 115%, all at the same time using your calculator. Okay, so your calculator, you could type that matrix in. And actually on the matrix section, I think the numbers get kind of big, so you might want to use a calculator on those matrix ones that are this is in 8.2, the 8.2 word problems. I think they're not all pretty numbers. So I think that using your calculator is a good plan. But know how to do it regularly. So basically you would type it into the calculator and you would just do 1.15 times matrix A, right? So see if you remember how to do that from the calculator one. You get this one from names, right? Matrix names. And then how do you type it in originally? How do you type it in? Remember, you type it in with a matrix edit. This pen moves more smoothly, but my handwriting's a little worse, so I'm going to get better. If I don't practice, then my handwriting's never going to get better. So we'll see. Otherwise, I'll change back to my other pen if it doesn't get better today in these videos. Okay, so that's it. Let me do it on the calculator, I guess. Let me show you so you could remember. Let's see. I can show you on the calculator. I can go to Wabbit-Emu. Okay, so I'm going to take a picture. Go over here. Wabbit-Emu. Let me look look at my picture on my phone. Technology, so awesome. Okay, so matrix. Okay, matrix. Edit. This one is a what size? So it's a 2x4 matrix. So 5, 5, 6, 7, 6, 7, 7, 8. What happens if you're working for a company and you're the orderer and you're ordering from Staples and these are all the prices, but you have to add the tax on them? You know, so you need the price with the tax. And then what if the new tax is a different price? And you're trying to estimate for your company how much things are going to cost. So all of these things are very helpful. And then they change the rate and the tax rate. And you're like, okay, now what? And then what do? Well, you could just change it, the number in the front. Okay, and that would work. So these are definitely some things that you could utilize to make it a little bit easier for you. Okay, so this is 1.5 times matrix A. So matrix A, I go back to matrix, I pick names, and there it is. And there's all my values, including the ones I did by hand. Okay, so let me take a picture of that one. And somebody did give me some feedback that said, hey, Ms. Nichols, we can pause on our own the video at any point that we want. So that is definitely true. Okay, so pause if you need some time to write that out. Okay, I'm going to go back over here. I was using OneNote. And my answer matrix is 575, 575, 690, 805. Let me write this neater so you can see it. 90, 805. So then these are the new prices. And these are what? These are the females, these are the males. This is the small, medium, large, extra large. Okay, and that's your new price. And then you have to decide, okay, am I going to change the sales or not? So this is saying that a company decided they were going to increase their prices to you 15% across the board. And then you also need to then add taxes, right? So what are you going to charge? Well, that's not really true, because taxes you don't get as your own money. Basically, you charge taxes on top of the shirts, and then you send that into the state. Okay, so we have one more question for this video, and that's it. This one, I used to have a really great one, so I'm going to try to do the same one. Okay, let's see. This would have been example, I believe, 4. Let me check my example numbers. Okay, and then this is example 5. Okay, so I had found this in a textbook, okay, at some point, and I thought this one was a really neat one. So basically, what it is these are teams, okay? So across is team 1, team 2, team 3, team 4, okay? And they're baseball or softball teams, okay? Baseball or softball teams, adult teams, okay? And they need a certain number of bats, they need a certain number of balls, and they need a certain number of gloves to start the season. Okay? Okay, so team 1 says, hey, we need to have 4 bats, we need to have 20 balls, and we want to have 5 gloves, because some of the team already has their own gloves. Okay, team 2, 2 gloves. I'm writing, just watch the way I'm writing though, so I'm not writing it all the way the same way. Hey, they want a whole bunch of different bats. They want 6 bats, and they only need 10 balls. Okay, and so team 3 says, hey, I'd like to order 3 bats. I'd like to order 20 balls, and we need 3 gloves. And team 4, they don't have very many gloves, so they need 10 gloves, they need 15 balls, and they need 8 bats. Okay, and the question is, how much is it going to cost per team to buy these things. So then we have the prices. Okay, so bats are, I have no idea how much bats are. Okay, so we're going to say a bat is $25. I could be so off. I have no idea. See, if I was teaching in a class, one of my students would tell me, then we would know. Okay, balls. Let's see. Let's have the balls be, gosh, I don't know that either. Let's have them be we'll have them be $7. They're probably like some decimal, but it'll be easier if we just have them $7. And the gloves, I don't know, are gloves more than bats? $42. They're leather. Okay. So what I want to do is I want to use matrix multiplication to find the cost for each team. Now, in the textbook and on this test, if we ever take this test, okay, but on the test, on the calculator part of the test, it gives them to you already in matrix form, okay? So, but I'm just assuming, hey, we don't have it in matrix form. How would we apply this in real life, okay? So, see the bat, ball, and glove? If I wrote the bat, ball, and glove this way, which feels right to do, okay, bats, balls, and gloves. I can't multiply them. Okay, do you see this bats, balls, and gloves? This is a 3 by 1, and this is a 3 by 4. You can't multiply a 3 by 1 by a 3 by 4. So now I want to be able to multiply them. Well, how would I multiply a 3 by 4 and a 3 by 1? Now, the bats, balls, and gloves and the bats, balls, and gloves are related, so it will make sense to multiply the two 3s together. Okay, but I can't do that. So if I do 3 by 4, what if I change that to a 1 by 3? So what if I change that to the other way? Well, these don't match, so it's not going to be able to be multiplied. So what if I put the 3 by 4 in the back and the 3 by 1 in the front? Okay, that doesn't work. So how can I make it work? How about a 1 by 3 and a 3 by 4? Okay, that's legal to multiply. So let's see how that works. Okay, so that's going to be our plan. You don't have to do this in your homework. And on the potential test, it's actually written in the matrix form that you want. So this one, we're going to actually do what's called a transpose, and we're going to do this instead. Okay, and this is still bats, balls, gloves, and this is like dollar signs, right? That was how much it cost in dollars. Okay, so I can multiply my 25,742, and the labels are going to be important. So, and it's going to help you understand why we multiply matrices in the way that we do. Okay, and this is dollar sign, and you're going to multiply it by this matrix, which is your 3 by 4. So 4, 6, 3, 8. And you're going to be able to multiply these by hand. I mean, not by hand. You don't want to multiply them by hand. You're going to be able to multiply them with your graphing calculator. Okay, there's just too many of them. Okay, but I want to show you how, by multiplying them by hand, how you can see how matrix multiplication was kind of developed. Okay. Okay, so we're going to just do one of them by hand, okay? So we're not going to do all of them by hand. We're going to do one by hand just so you can kind of see how it works. And then you will need to label your final matrix, okay? So you're going to get, let's check what our answer matrix should be. So this is a 1 by 3, and this is a 3 by 4. So remember when you're multiplying matrices, these kind of cancel, and you get a 1 by 4? Okay, so this is going to be a 1 by 4. Okay, so how are we going to multiply? So remember, you multiply the row of the first matrix by the column of the second matrix, and then you add the numbers together. So I'm going to write that down here. Row 1 times column 1. So that would be 25 times 4 plus 7 times 20 plus 42 times 5. Now look at what we're doing. Isn't this money? $25 times 4. Isn't that the total price for the bats? And then the 7 times 20 is $7 for each ball, and there's 20 balls. And this 42 is it's $42 for gloves times the 5 gloves that we need. And so this is the total price for team 1. Okay, so this is what, 100, 140, and 0, 121. So that's 310, and 140 is 450. Okay, so 450 would be right here. Okay, now what I want to show you, which is cool in the matrix, is do you see how matrix 1, I'm going to circle it in red, matrix 1 started with row 1, right? And what did the row 1, what was it labeled? It was labeled $sign. Oh, except I made my matrix the wrong way. I was like, wait, something's wrong with my matrix. Okay, so it was supposed to be 1 by 4. You guys probably caught that already, and you're yelling at the screen, Ms. Nichols, you wrote it the wrong way. Okay, so the $1 sign would be right here. Okay, so this 1, the label of the 1 is the label of the new matrix. And look, the label of the 4, let me do that in green. The label of the 4, which would be what? These are the 4 columns. The label of those 4 columns is the label of your 4 columns in the answer. Okay, so when you multiply the bats, balls, gloves, notice the 25 bats line up with the 4 bats. The $7 per ball lines up with the 20, and the $42 gloves line up with the gloves. So that's why we multiply in this weird way that we multiply for matrices. Anyway, so that's it. So what did we get for column 1, row 1? We got $400. We got 450. Okay, and then let's do the calculator, because I certainly don't want to multiply these by hand. Okay, so in the calculator, I'm not going to show you the calculator in this one. Well, I might as well show you the calculator in this one, so you guys can practice that again. Okay, let me get to that. Okay, so let me go to the calculator. Where's my calculator? Because I also have a calculator on my phone. Okay, so I also have a real calculator that's sitting on my desk, but I don't know, I have so much fun using the calculators on my phone. Okay, so matrix, edit. Now I have 2 matrices, don't I? I have my first matrix, so that is a 1 by 3. And really, when you're doing the multiplying matrices, it really forces you to understand the sizes, because if you do the size backwards, then you realize, oops, I put it in the wrong order. Okay, so that's a 1 by 3, 25, 7, 42. Make sure you type it in correctly. Okay, then matrix, matrix edit. I need to matrix edit my B. And what's that? 3 by 4. Okay, and when you're doing these notes, you really want to be putting these in as well, not just watching me. Because if you watch, you're not going to learn anything. You're not going to retain it. Okay, watching has you retaining almost nothing. Okay, oops. Okay, so you got to be writing it down, and you got to be trying it yourself. Okay, so 5. And try to answer my questions when I ask you, like, oh, what do you think that we should do? Try to answer them at home. Okay, try to guess. In class, you know, sometimes you guys don't want to say it out loud, but if you say it at least in your head, you will learn better. Okay, so I think I typed it in right. 4, 6, 3, 8, 20, 10, 20, 15, 5, 2, 3, 10. I would double check. Double checking is going to be really important. Okay, and then it was what? Matrix A times matrix B. No way, matrix A times, oh, what did I do wrong? That's so funny. That's so good. So A times B is 0. Okay, so what's A? And what's B? Oops. Guys, A and B are just numbers that I probably stored some other day. Okay, so remember, you want I honestly made that mistake, but that's funny. Okay, so A, matrix A times matrix B. That's so funny. I made that mistake. That's good, though. If you make those kind of mistakes, then you know what you did. Okay, there's my matrix. There's my 450. Okay, so I'm going to take a picture of this. Okay, I'm going to take a picture of that. And let's get out of here. Boom. Let's go back into OneNote. Flip my tablet around. Okay, and then we'll write the answers in here. And then on the test, or if this was real life, you wouldn't want to leave the answer in a matrix. Oh, wow, team 4 really cost us a lot of money. So it's going to ask you, what does this mean in real life? Okay, so what does it mean in real life? It means team 1 needs 400. Well, I shouldn't put T1, right? I should put the actual word. So this is team 1 needs 450 for their supplies, right? Team 2 needs $304 for their supplies. Team 3 needs $341 for their supplies. And team 4 needs $725 for their supplies. Okay, sounds good. I think we're going to want to have a test on this one, because the matrix test, Ms. Nicholas said it raises people's grades. So if we could figure out how to test on this one within our, legal construct of our closure here, that would be helpful. So I don't know how it's going to work. It might be impossible. It might be possible. We just don't know. Okay. Anyway, but that would be your word problem answer. This is on the calculator part of that test. Anyway, so that's it. That's it for this video, I believe. Multiplying matrices, percents, solving, Kramer's rule, collinear. Remember collinear, we're using the area equals 0, missing letter given area, and area using determinants. So that's it. And that is for homework number 54. Now, homework number 55 is a review homework. So this one video allows you to do 54 and 55 if you've done the other videos. Okay, and then I'm going to try to start on, I might just post those tomorrow, the 11.1 and 11.2, 11.3, the ones for 56 and 57. If I'm kind of slow, you can always send me an email. If you send me an email and say, hey, Miss Nichols, I'm done, I need some more, I definitely can make the videos faster. I'm just trying to prioritize different classes. Anyway, that's it. I hope you all are safe.